Why is cybersecurity vital for SCADA operational technology? Imagine a world where the lights go out, water stops flowing, or gas pipelines leak without warning. That's the real risk if we don't protect the systems controlling these vital services. Supervisory control and data acquisition systems, or SCADA systems, are the backbone of critical infrastructure like power grids, water treatment plants, and gas pipelines. They help monitor and control equipment spread across large areas, often using public networks. This makes them more exposed to cyber threats than closed systems. Unlike control systems that work in isolated environments, SCADA systems need to communicate over wide areas, which opens up more opportunities for hackers. These attackers can be organized cybercriminals, nation-state actors, or even insiders with malicious intent. They target these systems because disrupting them can cause widespread chaos. For example, if hackers manipulate pressure readings on a gas pipeline, it could lead to dangerous explosions or supply failures. The 2021 Colonial Pipeline attack showed how ransomware can shut down fuel supplies across the United States, causing panic and economic loss. Such incidents highlight how cyberattacks on operational technology can turn into national emergencies. From an electrical engineering point of view, SCADA systems control key components like programmable logic controllers, communication protocols, and control servers. Data integrity is vital because false data can cause incorrect decisions. If malicious actors inject false signals into the system, it can trip breakers unnecessarily or fail to trip during faults. This can damage equipment or endanger personnel. The threat landscape is constantly changing. Phishing attacks are common, but more sophisticated breaches like ransomware and network intrusions are increasing. Attackers include organized groups, government entities, and even insiders. That's why a layered defense is essential. Protecting SCADA systems involves multiple steps. Strong access controls and authentication methods are necessary. Segmenting networks limits how far attackers can move if they breach one part. Remote access tools like TeamViewer or ConnectWise need extra security measures, such as multi-factor authentication and activity monitoring. Regular vulnerability assessments help identify weak points. These assessments should look at the system itself, possible attack scenarios, and access points. Applying patches and updates promptly closes security gaps before hackers can exploit them. Electrical systems are now tightly linked with information technology, which increases risks. If cyber incidents compromise data or disrupt communication, the physical infrastructure can suffer. This makes cybersecurity a core part of system design and operation, not just an afterthought. Good cyber hygiene is the foundation of protection. Using strong passwords with at least 13 characters, mixing numbers, symbols, and uppercase and lowercase letters can make cracking passwords nearly impossible. Training employees on online safety and social engineering helps prevent insider threats. Standards like the North American Electric Reliability Corporation Cybersecurity Standards and IEC 60-2351 address these issues. They set rules for vulnerability assessments, data security, and communication protocols. Following these standards helps ensure systems are resilient against cyber threats. In the end, cybersecurity for supervisory control and data acquisition systems is about keeping our critical services safe, reliable, and secure. Without proper protection, these systems could be compromised, leading to economic damage, safety hazards, and even national security issues. That's why cybersecurity must be an integral part of how these systems are built, maintained, and operated every day.